Hello, welcome to another module in this massive open online course on the principles of CDMA, MIMO and OFDM wireless communication systems. And what we have seen in the previous module is that the poor performance of the wireless communication system can be attributed to the deep fade events occurring because of the fading nature of the wireless channel. And what we have seen, what we had also seen or hinted at is that we are going to use this principle called term diversity to overcome this deep fade effects, overcome this degrading nature of the wireless channel. So, what we are going to talk about today is we are going to talk about an overview of this principle of diversity. So, I would like to talk a little bit more at a high level about the principle of diversity in a wireless communication system. So, what is the principle? So, we said diversity can be employed, this can be employed to overcome this can be employed to overcome fading or to combat fading or to basically more precisely overcome effects of the deep fade, that is because the deep fade events have significantly degrade the performance of the wireless communication system. So, this can be used to overcome the effects of the deep fade, or also basically another way it is frequently stated is this can be employed to combat the fading nature of the wireless communication system. And the principle of diversity, what is the key behind diversity? The principle of diversity is very simple and it can be explained as follows. The principle of diversity can be explained as follows. Consider a transmitter and now consider a receiver in a wireless communication system, that is, this is my transmitter, and basically this is my receiver. And traditionally what we have is we have a single link between this transmitter and a receiver. So, what we have is we have a single link or single link between, or a single fading path between transmitter. We have a single link between the transmitter and receiver. Now, what happens if this link is in a deep fade? Let us say this is a deep fade event. If this single link is in a deep fade, then there is no path or there is no link to transmit the signal over this wireless channel. There is no link between the transmitter and receiver is disrupted, and that results in the poor performance of the wireless communication system. Therefore, if this single link is in a deep fade, it disrupts communication, right, because there is a single link, there is only one link, and if this one link is in a deep fade, then there is no route to transmit the signal from the transmitter to the receiver, and therefore, that disrupts communication. And in other words, basically there is no alternative link, there is no alternative to transmit the signal, there is no alternative link in this single link system, there is no alternative link which is not fading. So, there is no alternative link to transmit the signal from the transmitter to receiver. So, in this system the key is there is no alternative. There is no alternative to transmit the signal between the transmitter and receiver. Therefore, if this single link is in a deep fade, performance is bad. If the single link is in a deep fade, if single link is in deep fade, performance is bad or the performance. So, there is a single link. If the single link is in a deep fade, then the link is broken, that disrupts the communication, the performance of the communication system degrades and the performance is bad. That is the problem with our wireless communication system with a single link. And therefore, how do we improve the performance of this wireless communication system? Naturally, one simple way is to introduce multiple links between the transmitter and the receiver. So, another simple idea is to consider, consider a system with we would like to consider a system with multiple links, that is, I have a transmitter, I have a receiver as before. However, I do not have only a single link, but this time I have multiple links. I have multiple links. Now, observe that I basically have multiple links between the transmitter and receiver. Now, let us say a few of these links are in a deep fade, let us say 2 of these links are in a deep fade. So, we have 2 links if 2 of the links are in a deep fade, there are alternative paths. The important thing to notice here is that there are alternative paths, right. So, there are other alternative paths. So, basically the communication is not disrupted in this scenario because there are multiple links. Even if one or a few links are in a deep fade, there are alternative paths for the signal to propagate from the transmitter to receiver, hence communication is not disrupted. Therefore, communication is not disrupted when there are multiple links, and this having this multiple links or this alternate paths means that there is diversity in the system. What is the meaning of diversity? Diversity means that there are alternatives, right, means that there is not one, but there are many. Diversity by the very term means that there are many. Therefore, there are many alternative paths or there are many alternative paths or there is diversity in the system. So, when you have multiple paths, there is basically what you are saying is basically there is diversity in the system, or basically what it means is there are alternative there are alternative paths. Therefore, if a few of them are in deep fade, not everything is lost, you can still transmit the signal, or the signal can still reach from the transmitter to receiver via the non-fading paths, because it is possible, because there are multiple paths, it is possible because there is diversity in the system, and this principle where you have multiple links or multiple paths to allow propagation of the signal from the transmitter to receiver, there are multiple links, this is called as the diversity. This principle where you have multiple modes between the transmitter and receiver, this is the principle of, this is the principle, and this is an important principle, this is the principle of, this is the principle of diversity. For an example of diversity, as an example of diversity, consider antenna diversity. One form of diversity is antenna diversity, where let us say you have a transmitter, this is our transmitter as before, and this is our receiver. Now, you have let us say a transmit antenna, instead of having a single receive antenna, you have two receive antennas. So, now you have one link between, let us call this transmit antenna T1, let us call this receive antenna R1, let us call this receive antenna R2. Now, you have one link between transmit and T1 and R1, and you have another link between T1 and R2. So, now because you have multiple receive antennas, so what you have is you have multiple receive antennas, because you have multiple receive antennas, what you have is now you have multiple paths, you have multiple links between the transmit antenna and these multiple receive antennas, and this is how now you are introducing diversity. So, that even if one of these links fail, that is for instance let us say the link between T1 and R1 fails, you still have the link between T1 and R2. Similarly, if the link between T1 and R2 fails, you have the link between T1 and R1, and thus you are introducing, by these multiple links you are introducing diversity in the system. Thus, you are introducing, this is introducing, this introduces, this is introducing diversity in the system, and specifically where you have this multiple receive antennas, that is where you have this multiple receive antennas, this is termed as receive diversity. Receive diversity implies multiple receive antennas. So, now because of this multiple receive antennas, you have multiple links, and therefore, you have diversity, and this is termed as receive diversity. Similarly, you can have transmit diversity, where you have multiple transmit antennas, that is if you have multiple transmit antennas instead of receive antennas, you have transmit diversity. And why not both? You can have multiple transmit antennas as well as multiple receive antennas, that is even better, and therefore, you have both transmit as well as receive diversity. And it is not just antennas, we will discover later in this course that you can also have diversity in time, that is you can transmit the signal across different time slots, and this will give us different channels across different time slots. This is known as temporal diversity. You can transmit the signal across different frequency bins, this is known as frequency diversity. You can transmit the signal to different users, this is termed as multi-user diversity. So, diversity is a very important, a very key concept. There are many different forms of diversity, and one can exploit diversity to improve the performance of the wireless communication system, and diversity therefore plays a key role, a significant role, and also we are going to discuss it in our discussion in this course. It is going to play an important role when we discuss the performance of several wireless communication systems. So, diversity is one of the most important principles, one of the most important aspects that can be employed in a wireless communication system to combat the effect of fading, and therefore decrease the bit error rate and hence improve the performance of a wireless communication system. So, we will stop this module here, and we will continue with this diversity and discussion of different aspects of diversity in the subsequent modules. Thank you very much.